working on this. So, oh man, I haven't switched over to. Huh? That was the website that's in your syllabus, and I will be sending you a link to it. But you could. I sent you the syllabus in a PDF format. If you go to the second page and click on the link where it says class web page on the syllabus, it'll take you there. But I will send you the link in Jupyter as well. Good questions. Most of you are paying attention very well, and I'll speak to a couple of you one-on-one, right? All right. All right, so let's talk about this chemistry of life business. So, who has heard of a periodic table? All right, most of you have heard of it. What is a periodic table? Yeah.
A table of elements.
A table of elements. What's an element? Could someone close the door? So there's this word element. There's this word element. Yeah, it's very close. And that's the danger in the English language, in any language, is some words are very close to other words. Element, elephant, right? They sound alike, they sometimes look alike. It sounds funny, but if you're not thinking and you're not aware of your environment and you're not putting things into context, you can easily confuse element with elephant. You can look it up here and see element right away because we're talking about chemistry. And so you would be thinking about elements. If we were in a zoo, you'd be thinking about elephant. So you have to put things in context. Keep your mind in the game, as your coaches would say. All right, element. What is an element? Yeah. All right, particles. I heard particle. Well, the ancients, some of the ancients, the Greeks, maybe the ancient Chinese, would consider fire, right? Air. Earth. Yeah, the airbender, right? If you've watched that. Earth and water. And in fact, the Chinese would also call, I believe, I shouldn't speak about the Chinese because I'm not Chinese. I don't understand the cultures that well. But I believe there's something called qi, right? And qi is supposed to be this energy, right? So one of the major elements of life. So that's kind of the elements that they thought of, right? And various cultures have thought of different elements. So what? See, there it is again. Is that? Didn't close what? What's open that's making that noise? I'm just gonna close. I'm gonna close everything. It's freaky, isn't it freaky? It sounded like somebody was talking. I'm like, ooh. All right, so elements. Elements you can think of elements as just like, what does everything boil down to? When we get to the most pure stuff, right? Well, okay. This is an atom, right? It's a particle. Somebody mentioned it in the back, a particle. But it turns out that not all particles are the same. Does that make sense? Not all atoms are the same. Some atoms are big. Let's talk about some of the qualities.
Wait, what?
When I say big, I mean big relative to other atoms. Does that make sense? They're still all tiny. All atoms are tiny, but some atoms are bigger than others. The smallest atom is a hydrogen atom. There's another atom, so if I were to draw atoms and I drew a hydrogen atom, it would be like this. It's just a single proton. That's it. The smallest possible atom. And so we'll talk about that in a minute, but we're talking about qualities. You talk about a big atom like a uranium atom, and it would be giant. In fact, it'd be hundreds of these. So the hundreds of hydrogens would fit into a uranium atom. Now, they're both tiny little particles, but this one's actually a very big atom, and there's a very small atom. Now, there are consequences to that. Which one of these do you think would be light? The small one. In fact, this is so light that it's a gas and it floats. It's lighter than air. Hydrogen balloons, helium balloons. Helium is a little bit bigger. Helium has 2 protons, so it's twice as big as hydrogen, but still pretty small. So it's very light. A uranium atom or a gold atom is very big. So what do you think what's the consequence? This is very heavy. All right. In fact, we would call it dense, right? So a very small amount of this would be heavy. If I gave you a box of helium, it'd be extremely light. In fact, if I had a cardboard box filled with helium, and if it were sealed, and were a cardboard box full of helium, guess what would happen with that cardboard box? It would float away. Helium is so light compared to everything else around it. That being said, if you had the same cardboard box filled with gold or uranium, it'd be extremely heavy, right? Because there's more matter, more mass in this heavy atom than there is in this little one. We call these the heavy metals, or heavy elements, right? Big elements. So when we look at the periodic table, tomorrow I'll give you a periodic table, we'll go over it. We look at the bigger atoms, they're going to be heavier. So they're qualities that are specific. It turns out that there is one quality, one thing about the atom that makes it special, that gives it all its other properties, in part including density. Yeah.
What's that word under heavy?
Dense.
Thank you.
You're welcome. All right. So what would be the one thing that makes a difference between atoms is the number of protons. This is the one thing that determines everything else. How many protons does that atom have? So almost every other quality is determined by how many protons are involved. The number of protons determines almost everything else about that atom. And so that is what today we call elements. Our elements are determined number of protons. We call that the atomic what? Number. That's right. Atomic number.
I never knew that.
The atomic number is why are you putting stuff away? You haven't taken notes all period that I could see. Maybe you haven't, I didn't notice it. But you haven't taken notes all period, and then you're putting stuff away. Now, it's going to be a long discussion after class. Atomic number. So the atomic number determines the element. So hydrogen has an atomic number of 1. So if you have one proton, just one proton, then we call that hydrogen. No matter what, no matter how many neutrons or electrons or anything else it has, if it has just the number of protons, if it has one proton, it's called hydrogen. If you have 2 protons, atomic number 2, we call it helium. If it has 3 protons, we call it lithium. If it has 6 protons, we call it carbon. If it has 8 protons, we call it oxygen. What? What's funny? What's wrong?
It's about go to, I think they're trying to say go too fast.
What's written on the board?
I'm saying.
So this is just, I'm not expecting you to memorize these. I've memorized a lot of them. I don't know all of them, but what you discover, lithium.
Yeah, okay, see
Did you skip some numbers?
Yeah, of course, sure. Is that better?
I didn't make my brain hurt.
What's making it? It's really not that hard. It's a real simple.
What you did.
Oh, thank you. But it's really not that difficult a concept. However many protons you have, it tells you what the element is. That's it. That's all. I mean, that's just a simple relationship. It's one of those things you got to put an index card and memorize it. You just got to know it. You're going to need to know that for chemistry. You need to know it for biology. So number of protons gives you the. Now here's an interesting concept. I used to have kids walk through a lot of this, but we're going to go ahead and skip some steps here. If you're not taking notes, it's really bugging me because I think we're done at 55, are we not? So it's 54. So we still have a couple minutes left in class. And now I'm wasting those couple minutes trying to tell you to stop whatever it is you're doing and focus on what you should be working on all the time. That's a problem for me. So number of protons, the protons are in the nucleus. So protons are positively charged, protons. There's another part to an atom called a neutron. A neutron is neutral, very good, has a 0 charge. This is a +1. And then on the outside of the nucleus, these atoms have nuclei, which are both, they have the protons and the neutrons. They have the zeros and the pluses. On the outside of the nucleus, there's these orbitals. They're not really orbits like the planets orbit the sun. They don't really do that. They have this kind of a range, an area, space. But this range or area or space is called an orbital. This is where we find the electrons. So we have protons, neutrons, and electrons. Those are the particles that make up an atom. So if you would take any substance, you take gold, and you break it up into smaller and smaller pieces, you can break it up to its tiniest piece, then you've reached the atom. That atom is made of these 3 components. Then each of these is made of other smaller pieces. So these used to be called the fundamental particles, but they're not fundamental. There's something even more fundamental than this. We're going to have to leave it here, but this is the direction we're going to go. Tomorrow we're going to talk about how these atoms bond, what the different kinds of atoms there are, and we're going to talk about that ready experiment. So tonight you should be looking at the lab reports and looking at that ready experiment. All right. I hope you feel better about your exam. So when we're looking at this, and you're looking, you see here that they're in the nucleus. Now, this is a very simplistic drawing. Atoms don't really look like this. If I were going to try to draw an atom accurately, it would be, and even then, I don't know if I could do it accurately, but it would be something like this, right? And it would have in the very center of it, at the very, very center, to be a tiniest of little dots, and that would be the nucleus. And then everything else on the outside are layers and layers of electrons swirling around in some unpredictable, well, there's some predictability, but in some fairly unpredictable patterns. And so I think you agree, is not very useful, right? I mean, you all agree on that?
Yeah.
So we draw it like this, and we say we have orbitals. So we think of it like the moon going around the earth, but that's not how it is. It's just easier to think about it that way. And so there are layers and layers and layers around an atom's nucleus. And the nucleus is really tiny. So if I were going to, who's been to the stadium? Who's watched a baseball game or a football game at the stadium? So imagine a baseball in the center of the stadium. And now go all the way out in your mind, go all the way out to the edge of the stadium, all the way up in the bleachers, as far away as you can possibly get and still be in the stadium. That is the distance between the nucleus of the atom and the outside of the atom. So the nucleus is really tiny compared to the size of the atom. It's the smallest part of the atom's nucleus. But here's the weird thing, is that center, this nucleus, has most of the mass. All the mass of the atom, the heaviness that we talked about, gold being very heavy, all the heavy part is right there in the center. These electrons, they're what we call negligible mass. It's like 0.000001 of a proton. Very, very tiny mass. They're so small that they're irrelevant. We call it irrelevant, right? We can ignore it. They're negligible. We can ignore the mass of the electron. So why do we even talk about the electron? Because this is the important part. This is actually the part that we talk about in biology, because this is the part that determines the chemistry. Whether something reacts with something or not, whether it blows up or it doesn't blow up, it's because of these things called electrons. This determines how heavy it is, how big, how heavy it is given a certain amount of volume, how dense the material is. So when you're talking about an atom, there's these different parts to it, and it can get really complicated very quickly, all right? And you can talk about these things called valence electrons, which are the electrons in the outer shell, and you can talk about all kinds of crazy things that I used to try to teach, and it's not crazy. It's very interesting, very predictable, fairly straightforward. But what I find is that when we start to try to describe it and explain it, kids spend a lot of time trying to get that, and then we miss the point. Because as far as biology is concerned, this is incredibly important. And to really understand biology, you have to understand chemistry. But at this point in your academic career, right now, it's not time to leave, so don't put things away. We still have plenty of time left. At this point in your academic career, I think it's more important to just get a little quick intro to this chemistry and then focus on knowing what you need to know. Why? Let me pause. So there's three components. So what is it that you have to know? So if you're taking notes, this would be, all this here, right, would be, if you're doing Cornell notes, and you all should be, all this here would be the details. And what you would have besides the header and the title, right, you would have, of course, your title would be what? The chemistry of life. And you would have what? The atom, elements. You would have proton, neutron, electron, you would have probably charge and mass. So those are the two important ideas. What is it I have to know? Do I know? So when I sit there and I cover up this detail, when I sit there and I cover up this detail, do I know what an atom is? Do I know what an element is? Do I know what the charge and the mass and the proton, neutron, and electron are? If I know that, then I know the purpose of this page notes, and I can go on. I can use this to check my understanding. Is that clear? I want to emphasize that this is what makes Cornell Notes so powerful. So make sure you're using it, covering up the answer, the details, and quizzing yourself, or covering up the answers and trying to figure out what's important. However you want to study, you can study. Don't forget to summarize the notes here. What's important, what is it you need to know, and we'll continue this tomorrow. Good luck. Make sure you're accessing. Remember, every night you should be practicing, studying, and learning. Specifically this week, make sure you're going over how to write a lab report. Otherwise, you're going to be struggling over the weekend trying to write that lab report. So what we have here, and I hope that you're all paying attention, what we have here is you need to know what the mass of each of these are and what the charge of each of these. And so when you're looking at a proton, it has a charge. Let's go ahead and say charge. And mass and particle. It says part, but since that bothers you, let's go ahead and put particle. Is that better? Okay. You don't want to go see Oshak Hennessy. Oshak Hennessy, just remember that.
Oshak Hennessy.
Particle. So a particle is a proton, the neutron, and the electron. The proton has a positive charge, +1 charge. Let's just go ahead and put +1. A neutron has a charge of 0. I put a line through the 0 so you know the difference between a 0 and a 1. I mean a 0 and a O. Thank you. And man, I don't know what's wrong with me lately. I am not writing very neatly. I heard that. Electron. An electron has a what? -1. That's all there is to it. And it's not hard, but I'm going to tell you that what happens inevitably is students don't memorize it, and you're going to run into problems not just on the quiz, not just on the test, but then you run as we move along and we start looking at DNA and RNA, and we start thinking about positive and negative. You don't know what the heck is going on. When I tell you there's extra electron on it, it should make it then what? It should be, exactly, it should make it more negative. But people will put more positive instead. And when that happens, you get all confused. So it's just like reading in English. If you don't learn your alphabet, it's going to be real hard to learn how to read. Right? So make sure you're getting these basics in your head permanently. The mass of a proton is 1 AMU. 1 AMU. That's AMU is atomic mass units. You don't have to know that, but I know people ask what an AMU is. It's just a number that physicists have come up with. I'm not going to get into how and what and why. The neutron's mass is 1 AMU. So they have the same mass, protons and neutrons. It's just neutrons have no charge. Electrons' masses are, this is going to be very important. We're going to say they are negligible. You can ignore it. Are we good? Negligible. Yeah.
Did that say
AMU. Atomic mass unit. Atomic mass unit. AMU. Say what now? Negligible means you can ignore it. Ignorable. Does that help?
Yeah.
What I mean by that, when I say it's negligible, when I say it's you can ignore it, give me, somebody have a weight that they don't mind sharing with the class, their weight? Yeah, what is it?
186.
So he's 186. So if he's standing on a scale, wow, it's so rude. If he's 186, he's on a scale, and his buddy wants to make him ineligible for wrestling today, so he wants to put him overweight, wants to put him in a heavier class. He sneaks up behind him while he's on the scale, and he puts a little bit, just one speck of dust on his back. Did that make a difference?
No.
You can ignore, it did make a difference technically,
Yeah, well, it's not.
but it didn't make a big enough difference for it to register. So that's what we mean by negligible. The electron's so small, as far as mass is concerned, we can ignore it. It does have mass, is a fraction of 1 AMU, but we're just going to ignore it because it's so small compared to the mass of the protons and neutrons that it doesn't really impact the mass of the atom. Are we good?
Yeah.
All right, so that's what that means.
I'm gonna write my notes on that.
All right, so what is the summary that we have here? Know the three particles that make up atoms. Their charge and mass. Also, what an element is. All right, that's it.
This is make up atoms, right?
Make up atoms, right? I shouldn't put make up like that, should I?
Can I say there?
There, yeah, THEIR. Are we good?
You know I'm not know, right?
So that's what you need to know for that section. Let's move on. It's going to be 27 minutes, but probably make it a little more efficient.